Okay. So yeah, hi guys. This is Chris from DoraHacks. It's been a while, but it's great to be back to host another live stream sessions. And for today, it's the Polygon Global Tour, DevX Global Tour Hackathon workshop sessions. We have been supported Polygon DevX Global Tour starting from the very first stop. APAC and then EMEA region, and right now it's come to the American regions. And today we are very happy to have Abdul as he is the senior smart contract engineer from Trust Wallet to join us and give a workshop about how to master EVM, UX, security, and AI in blockchain applications. Yeah, so I think without further ado, we can have Abdul to start. But before that, please keep in mind that as the audience, if you have any questions for the workshop or for either me or Abdul, please feel free to left your questions in the comment sessions, and we will ask those questions for you. So yeah, Abdul, I think it's your time. Feel free to start.
Yeah, thanks, Chris, for the introduction. So, hey everyone, welcome for today's workshop. And today's workshop, as the title, we're gonna try to delve deeper into EVM, and the main goal for this workshop is mastering some parts of EVM that are crucial for user experience security, and how can we use AI and especially LLMs to enhance blockchain applications, especially on the end user. So my name is Abderrahmen, but everyone calls me Abdu. So this is my Telegram, Twitter, and GitHub. If you want to reach out, if you have any questions, if you need any support, please reach out to me. So our workshop gonna have two parts. The first part is gonna be about EVM logs, and we're gonna try to see how is it doable to build a mini transaction explorer. Part two is more about transaction simulation, and we're gonna understand in details what is transaction simulation and how it can be beneficial to the blockchain ecosystem and especially users. At the end, we're gonna see how can we use AI to enhance the user experience and simplify the user journey using blockchain application. So I think we should start with a reminder. If you are new to the blockchain or if you've been around for a long time, doesn't really matter. We should always remember that blockchain at its core is just a specialized database. But like traditional databases is decentralized and immutable. And that's set the limits or set the difference between Web 2, 2.0, and 3.0. Now we are operating on databases that are decentralized and immutable, and we're given access to the user for their own privacy and data. So yeah, the use of blockchain is mainly to offer user transparency, security, and resilience. So now let's go to EVM. EVM at its core have two type of data. One is called the state, and the other one is logs. So states, you can imagine it as the current state of the blockchain or the ledger, and logs are more historical. What does it mean? The state stores variables like account balances, smart contract data, and the change over time after each transaction. So each transaction in the blockchain, and more specifically in EVM, is just a change of state from X to X prime, and that's what is tracked in the blockchain on the ledger. So in each block, we can know the changes of the state, so we can ensure that the consensus and using the consensus, we can make sure that this data was not tempered, and we can track it even to the Genesis block. Logs on the other side captures and stores events. So we're going to see what are events and can't be changed once written. means like once an event have been emitted, there's no way to change the same event. But in contract, when it comes to state, is it possible to make this state immutable? Obviously, we need to have some kind of authorization there for the user, but that's within the hands of application developers or smart contract developers. But when logged event is emitted, let's say that's going to be stored always there, that an event being emitted, and this is how we can, let's say, query it historically. So states. The state is modification. The modification of state require gas, and it's costly compared to logs to interact with. So creating logs costs less gas than changing EVM state, and this is mainly the main differences between logs and state. So I guess that's an introduction to what are logs, what is state. But as I mentioned at the start, the main goal of this workshop is to explore logs in more details. So I'm gonna stop sharing the presentation for now, and I'm gonna share my screen, and we're gonna delve directly into writing some code using different libraries, and we're gonna see how we can interact with the logs of a blockchain. So here, sharing my screen again. I guess, let's see this. So yeah, I hope you can see my screen now. So yeah, this is the TypeScript project. You can see it's pretty simple. So you can see the packages here. It uses a bunch of npm packages, which like .env, ether.js, tsnode, and TypeScript. Most of people are familiar with this, but we're going to see the use of each package, but mainly is ether.js we're going to use a lot. So .env, tsnode, and TypeScript are mostly used during dev, so they should be even installed as dev dependencies, but yeah. So this is the structure of the project. This is the main. So what we want to do here is to check a transaction by its hash. So every transaction at every block is a bunch of transactions, and each transaction has its own hash. So we took an example of this transaction that we can track it here. You can see it. It was just picked randomly. So this is the transaction. It have a call data, it have all the params, and you see here the state, how it changed. We see here a change in a state. This is what I was talking about, the change of state. And then you can see here logs, which are events, and we can see that there is an event that's been emitted. So the goal for us now is to use this transaction by its own hash and try to see what really happened. We can see here on Etherscan that the main information from here are that this is an approval, so which means like rapid it being approved. And let me check first if I'm not sure if Chris is still here, but I'm not sure if like you can see my screen. So let me check it.
Yeah, I think we can see the screen.
Okay, thank you so much. I just got paranoid about it. So yeah, as I was saying, so we're going to focus more on the logs here. This is Etherscan. It's very well known. It's very advanced. So we're not going to build an Etherscan right now, but we're going to see how the core technologies or the core implementation that leverage this and allow users to see, or allow anyone, even developers use Etherscan a lot to see. To see the main actions. You see here transaction actions. So there is ERC20 approval. But if you go, for example, we can see, let's say, if we go to say this transaction, you can see also there is not only approval. There is, for example, withdrawal. So how user can know that there is a withdrawal or a transfer. All of that is leveraged by, you see here, that's an unwrap. And you can see here it's a log. So there is all of this action or all of these informations about any transaction are tracked mainly in the logs. And as we saw before, logs are not as expensive as state, so we can customize the logs to communicate informations, especially, let's say, to other third applications, for example, here Etherscan. And so, yeah, let's go and see. So this is a transaction hash. And here, as I said, I'm using EtherJS. There is also Web3.js, so you can use both, any one of them. There is other also libraries, but most known are EtherJS and Web3.js. So we're going to use here EtherJS. So the first thing we're going to do is we're going to create a provider. So what is a provider? In a nutshell, a provider is just an RPC node, because to interact with the blockchain, you need to interact with a node. As I'm pretty sure, let's say, what is even like a blockchain, what is a network here, we're going to interact with Ethereum mainnet. So Ethereum mainnet is just a bunch of nodes that run EVM and need to follow some kind of consensus to agree on the transactions. So in order for us to get any data from that, we need to connect or communicate with one of those nodes, and so we can get the data or send transactions. So provider here, as I said, is just the way of connecting with one of the nodes. So here, the providers, EtherJS offers multiple ways. It can be customized to interact with RPC nodes. So there is, for example, this is the basic one. So you just provide a new URL. It's like similar to HTTPS, just what is the host. But also it have, let's say, Infura, for example. So here, this is Infura. If you have a network and project ID, you can see here, and you can directly provide that rather than URL. Also, it have maybe Alchemy, and you can see here all you need is just the network and the API key. It have a bunch of providers, and for the sake of simplicity, we're going to use just JSON RPC provider. So yeah, then we need like a URL of an RPC node. So there is many ways to get an RPC node. It really depends on your application. And because this is just a simple demo, we're going to use any public free API nodes. On the other side, you can get your own gRPC from node providers. As we said, like there is, for example, NodeReal, there is Alchemy, there is Infura, and the list is so long. So here, what I'm going to do is just go to chain list. I'm going to see here if there is any public IUC. This is a bunch of public. I'm going to stop sorting so I can see. So I'm going to use the first one. It looks cool. Privacy is fine, score is fine, latency is fine, and it's synchronized with almost latest height. So yeah, we're going to use this. We're not going to put it here directly. I guess we can use, it's already here, so I'm going to use it from environment. So process. So we got our RPC node. So this is the provider. And now we got the provider set up. So now we are ready to connect or communicate with an RPC node. And you can see here, I mentioned it's a mainnet because here we are connected to mainnet. If you want to connect, let's say, to Binance Smart Chain, you connect to Binance Smart Chain. If you want to connect, let's say, Arbitrum or any other blockchains, all you need is to connect to the correct RPC node. So then next, as I said, what we wanted to do is to get all the information we need, and specifically logs of this transaction hash. And we can do that simply by using EtherJS again. So what we're going to do here, we're going to call it transaction. Here we have a provider. So get transaction receipt. Okay, so this is a transaction receipt. We have a transaction hash. This is a transaction hash. And then because it's an asynchronous, right? So we need to wait for it. This isn't going to be gRPC, similar to any HTTP call. So it's going to reach the node provider and wait for it. So it makes no sense to make it synchronous. So it's asynchronous. And then simply let's do the magic
Abdul. I'm not sure what. Hi, Abdul. I'm not sure why, but your voice is cut down. We cannot hear you anymore. The video is fine. We can see your screen, but we cannot hear your voice suddenly.
Oh, sorry. Can you hear me now?
Yeah, right now it's good.
Okay, yeah. Okay, let me repeat the last part. I hit some button here, so the mic was muted. So yeah, as I was saying, so we have the provider. We connect to the provider, then we use the provider to get transaction receipt, which is just a function that Ether.js leverage. So here, as I said, we need to wait for it because it's promise. Then we use the best trick of any developer is just to console log this transaction and see how it goes. So yeah, I'm gonna run it again. So here I'm using TS Node. So TS Node allows you directly to execute TypeScript rather than compiling and then like running Node.js. So TS Node, so we go src in main, and we got our results for this transaction. So the transaction itself, it have details such as the to, which means like this transaction. Let's start with from. From is like who sent this transaction and signed it. Who signed this transaction? So we have these others that signed this transaction, and to, let's say, the to address, let's see where it was sent. So here it was sent to this contract, which is, we're gonna see it. It is just rapid it. So contract address, the hash, this is the hash we sent, and the block hash, like each block have a bunch of transactions. So here it shows you that this hash was part of this block number that have this hash, and the block and the logs blossom. We're gonna see how we can use this directly. This is for mostly for index. We are not gonna cover it that much. So it tells you also like the gas being used there at the time, how much was, and the price. So one thing that is not visible here is the logs. Not every transaction have logs. Logs are optional. Some transaction won't emit any logs. So you can see here it's optional. So we are checking if it is null first. And then let's see here if we console log only the logs of this transaction, what we're going to see. And yeah, as you can see here, it's an array. It's a set of a bunch of events. Here we have only a single event. So saying if this transaction, let's say, resulted in multiple events to be emitted, then we're going to see more than one. If there was nothing, now no event, then this array most probably going to be empty, or logs completely going to be null. I guess it's going to be just an empty array. So this is the log. It's telling that this log was part of this transaction hash, which is fine. We have the block hash again, all of this data we already know, the address, and then we have our main two data we want to understand from the logs, which is the data and the topics. As you can see here, topics is an array of byte 32 chunks of data. You can see here, maybe you can notice that this is already padded, means this, in this case, we didn't need 32 bytes, but we needed less, so we needed to pad it. So this is how topics are organized. It's 32 bytes each. So even if you have, like, you want to return only true, then it's going to be 1 and a bunch of zeros here. And this is data. So let's try to understand, as I said, what is data and what is topic. So as per EVM specification, topics, topics is always going to be an array where the first element always exists. It's going to be always there. And the first element is the identifier of the event. So let's go here again to Etherscan to see it. So you see here this withdraw. It's an event if it's named withdraw. So now imagine we have another event that is named withdraw, but it have different params. And that's going to create problems because we don't know which event was emitted. So how EVM solved this is to create what's called event signature. So the event signature is the name and then all the params of that event, the types of params. So this is going to be withdraw, address, address. So we can take it here, and so this event, so basically this is not withdraw, right? So we are fine with that. So let's see our example with transaction. So this is a transaction we wanted, transaction hash. Yeah, correct. We go logs, events. So here you see, this is the topics, right? So this is the first element, right? So and it's here. So we are correct. But again, what does this, from where this comes? Because it always exists there. So this is just the ketchup of this identifier. So every event is identified by, let's call it here event signature, which is ketchup, and then what we're gonna do is just a string. So approval, and then what we do is we just put the types. We don't really care about what is the name of params, but only the types. I'm gonna explain this in a second. Okay. So we have approval. This is the name. The first param is an address. The second param is an address, and the third param is uint256. So let's imagine we have another approval, have the same name, but it have different params, right? So the first param is not an address, maybe, or maybe it have only two. So because this is a hash, so the signature is not going to be the same. So this is how, let's say, EVM makes sure that there is no events collusion. So we can know that this is an approval address uint256. So if we check this, we should see the same. Run it. Oops, something wrong. But it's like, okay. See, so this, it doesn't accept string directly, but it accepts strings, bytes. So I need to make it as bytes first, and then we can use it. Okay, so you see here, we got the same first element. You see, this is, we calculated this manually, right? So now let's say it's different. So if it is different, it's this, have the event have the same name but different params. We know that it's not going to be the same. You see here it's changed. So as you see here, the first element is just the signature of that event. So will you do it here again? Yeah. So let's try to see if how that can be used. So if we go through all the logs and see here, and let's say if the event topics, the first element, right, is equal event signature. So some of them, I guess, are checksummed. So both are lowercase, so it's fine. Is event. So we're gonna console log, let's say, approval found. So hopefully we're gonna see just one message saying that approval found is an ERC20 approval. Okay, cool. So let's make it clear. ERC20 approval. How were we able to know that? Is because we know already the event of ERC20. So if you don't know ERC20, so this is ERC20 standard, and it mentions here what are the names of the functions that every developer should use. So we have this synchronization or orchestration between tokens and applications. So it's mandatory to implement certain functions like name, symbol, decimal, total supply, and so on. And then also it talks about event. So it says this is the event transfer. The transfer should be transfer the name. The first element is an address and represent the from. The second element is an address again, present the to, and third element or third param is just the value. And as you see here, approval also, it says approval, the name is approval, first param is the owner, the spender, both are address, and the last param is a value. And so this is how we can identify that this is ERC20 approval signature. And it's event signature, right? So in any log, in any transaction, in EVM, if you find that the first element of a topic have this ketchup value or hashing value, that means it's an ERC20. So this is how Etherscan here can know that this transaction was the action of this transaction was, let's say, rapid ETH approval. No, it wasn't approval. It's an ERC20 approval, because rapid ETH is ERC20 is by decoding the logs and seeing what is this, and can link it with the event signature, so it knows, okay, this was an ERC20 approval. The same thing applies to transfer. If the transfer, as we saw here, is not going to be approval, but the name is going to be transfer. So, okay. So here we knew that this is an approval. Okay, so we solved the mystery of the first element. Now we still have second, third element, and the data. So the main idea here that when it comes to topics is going to be always an array. The first element is the event signature, and the next elements really depends. It's not always two, but in ERC20 should be two other elements. Those are the indexed params of that event. So what is different between an indexed param and the normal param? So let's go here and see. Yeah. So as you can see here, approval, this event, this param, which is the owner, is indexed. Also, the spender is indexed, but the value is not. So the index in EVM specification allows third-party applications of or external or off-chain query of, let's say, an event associated with this owner directly, with the indexed value. You can imagine as an indexed value in any other database. If you know that you're going to query your database in Web 2.0 by ID, so it makes sense to make the ID indexed. So later it's very fast to get it. And if you know, let's say you're going to query it, for example, by amount, then it makes sense. Let's say, I mean, amount most likely is not going to be indexed because it's not, how to say, it's not fungible amounts. So the index is similar to database, normal database Web 2.0. It allows us to query very fast and with efficiency an event that is associated with that index. So, as I said, the mapping here, or I'm sorry, the array or the set is going to include always the indexed params in order. So the first param is going to be the owner here. The second one is going to be the spender. And now everything else, whatever remaining from params, is going to be here encoded in the data. So we knew that. So here we know beforehand that the second param of topics is the owner. So let's take this. Let's say owner is equal topics This is the second element. And we know also that the next one is spender, right? Spender is index 2. How we know that again? It's just the specification. We know that beforehand. So this is the spender, this is this. And then we know that amount is the data itself. So here we can say ERC20 approval, and we can say here owner is this, and spender is this, amount is amount. Let's run this and see how it goes. Okay, so now it's an ERC approval. This is the owner, this is the spender, and this is the amount. But again, if we go here to it, if you go here to Etherscan, we see it doesn't look the same, right? Token approval. Here you see here this is an address, so it looks a little bit similar to what we did or what we got, but this looks like normal address, but ours is not. And I said this before because it's padded, right? So we can do this very easily. We can just remove the padding from here, or we just convert it to one address. How can we do that? So there is two ways. One is like not the best way to do it, and it is pretty simple. It's just you take this and you play around with the string. So you slice these paddings here because an address is 20 bytes. So we know it's going to be 40. 40 is here, and then you just add 0x. But the best way to do it is to use, let's say, a decoder, an ABI decoder, because all transactions, all the data, called data, is encoded with ABI specification. So, and this, we're going to see ABI coder, ethers.ABI coder. As you see here, we create a new instance. So what's the role of this ABI coder is going to help us, let's say, to code and decode and encode the data. Here in our case, what we want to do is decode. So we decode this. So the first param is the types. It's an array of types. So we know that this is an address, right? And then this is the data that we want to decode. Put it here. Okay. This is my bad. Hopefully we should be fine. This is again this decode suspender. So let's see if this is not gonna fail. You see. So now we decoded this byte 32 bytes into an address, and for both the owner and the spender. Now the amount is still hexadecimal. So, and we know here from the EIP specification that is in UN256. So what can we do? We take this type from here and we do the same. Here is UN256. So amount again, we're going to use the same technique. It is ABI coder. We decode. This is the byte 32, where the first param is just the types. Here we have only one type, UN256. And hopefully we should see. So this is, I guess, is going to be a big int. So let's put it as a string, convert it to a string. So it shows normally. And yeah, so this is the amount, this is the spender, and this is the owner. And we can see here we got the same data that Etherscan was showing us. So this is the value. It's the same for us. You see here, we have the spender. This is the spender. Here it's called the guy and SRC. Okay. You see, we have it here. And then we have this also, which is the owner, and we got everything correct. So yeah, this is how can we decode it. So again, this is only one way. And you can see here, then you need, let's say, to know what is the event signature, and you need to decode and encode. Hopefully, EtherJS offer us something called interfaces. And interfaces, all you need is just to initialize it with an ERC20 ABI, for example, with an ABI, and then it offers you multiple functions that we're going to see here how it works. So yeah, let's do this. We're going to change. You saw here that we use the ABI coder. We calculated the approval signature of ERC20. And we did this only for approval. Now, if we want to do it for transfer, then we need to do for transfer also. We need to calculate. And if we have, let's say, tens or 20s of events, then we need to do this for each one of them, which is like annoying a bit. And hopefully, fortunately, EtherJS can help us with this, so we can enhance better our code. So what we're going to do is just we're going to remove all of this for now, and we're going to see a different approach. For this, we can, it's fine, let's remove. So, so EtherJS offers something called interfaces. So all you need to do is new EtherJS, and you call the interface. And what is the param here? As you see, it's the ABI. So we can get ERC20 ABI pretty easily. Let's see it. So I have it here in another branch. So now need so we don't need to. Okay, I have here the ERC. So what I'm going to do is I'm just going to delete this, and we do it together. Okay. So why I switched this branch? Because here I have something called the ABI. So the ABI, you can get it pretty easily. For example, here this is rapid eat. For example, from Etherscan contract, we go to contract. Then I guess you scroll, and this is the ABI. So this is the contract ABI. So you can copy it like this, and then just put it here, and we should be fine. You see? I guess I didn't need to switch to other branch, but yeah. So we went here to the token itself. We grabbed our ABI, grabbed the ABI from the token. We can find this on Etherscan mainly, or maybe in the smart contract documentation or GitHub. So yeah, I'm gonna revert back to my previous one, as this is like the official one. Then yeah, here we have our ABI, and as I said before, we can create an interface of ERC20, which is gonna be just an EtherJS interface, and here we put our ERC20. As you can see here, the type is an interface. Then what we're gonna do is we're gonna do the same for each. We go logs, then we go for each. So this is the same thing we did before. And what we want to do is just to console log. Okay, what we want to console log, we're gonna console log the same event as it is. You see here, we didn't want to, we're gonna just console it. And then what we want is parsed event is, because let's do it again here so we don't get confused. So here it's going to show us the event as it is, but we still, we need to do the same thing we did before by calculating, let's say, the approval and coding and decoding. What I'm trying to show you now is a different approach and an easier one. Is using directly the ABI and leveraging EtherJS interface. How can we do that? As you can see here, we don't see the params as we want to do. So what can we do is parse it, and then we use our interface. This interface leverage or offers multiple helpers and functions. One of them, let's say, as you can see, decode errors, decode function data, and one of them decode event log. And this is what we're going to use. Also, it helps you, let's say, if you want to encode, right? Encode data, or let's say loop through all events, and maybe even get events and errors. So within this, what we're going to do is decode, I think decode or parse. Yeah, parse log. So this is the log we want to parse. And you can see here, we need to provide topics, which we can get easily. We already have that, topics. And then we need also to provide data, which we already have. Okay, TypeScript, I guess. Read only string. Okay, topics as Okay, cool. Now let's see how it's gonna look. Okay. So now we see that the event is parsed. It's telling us the first address, the second address, and the amount. And it's similar to what we did. So what can we do is we can implement the same thing we did before. We're gonna do the same thing. And first element we said, which is the owner, spender, and amount, right? And then we're gonna see it here, console log, and it's gonna be ERC20 approval where owner is owner, spender, and we have amount here. Parse log. Okay, what is this returning? Log description. Okay, I guess what is parsed here? Parsed is args. Okay, so yeah, because you see here it's more data we need. You see, we have the name and we have the signature and we have the topic, which is we calculated before. So iter.js is doing this for us. It's telling us what is the event and now the topic and what is the signature. You see here address uint with the name approval, which is we already did here manually. So again, iter.js is doing the same thing we did, but in a way that abstracted, so you don't need to worry about it. So here it's going to be topics. Okay, must have, but bro, I'm sending you topics. Okay, no problem. Parsed topics. Sorry, I'm using the wrong one, man. Okay, that's why. So it's args, but still can be defined, which is it's fine. We're gonna check this. Why it's happening in a second. Yeah. So as you can see here, we have the owner, we have the spender, and we have the amount. So I guess this is more of like TypeScript, so it's not really a big issue. As it is saying, here's any args, it's result. Yeah, there's possibly to be, let's say, possible to be undefined. So this is, let's say, args. Let's just do it the best way. So actually, we can do it like this. If args, then we can do this. Why is this easy? Description, args. Okay, fine, no problem. Log description. Again, let's just ignore it for now. Yeah, mainly, again, this should work also. Yeah. So yeah, we saw now 2 ways of doing it. One is doing it manually using approval signature. As you can see here, we don't need it anymore, but using directly the interface of ERC20. So yeah, I think this is pretty much for this. We're going to talk about something else, which is simulation for now. So now I'm going to share again the presentation. Okay, 1 second. So as we saw before, like that's how mainly, let's say, for example, block explorers can know in an abstract way, in a generic way, what was the main actions in the transaction. It's already pre-agreed EIPs, and as we showed now, there is many libraries that can help you doing that. So this is regarding all the events that happened. So simulation now, it is the idea of a way for us to know what's going to be the outputs of a transaction before it happens. So you can see here at local emulation of transaction execution. It works in a way that what can we do is to simulate, or in the sandbox, is we have, let's say, a transaction. We don't send it directly to the mainnet, but what we do is we fork the current state of a blockchain and we execute it locally, and then we can see, okay, this is what's going to happen in this transaction. Why do we need this? Is to help users to make better choices by showing them the outcomes of a transaction, even though that it's not really submitted. So a user can see, let's say, the outcomes of transaction, and then only if it agree on, then he's gonna do it. So how is this possible? How can we do this? So we can directly, let's say, call the, for example, here, get Go Ethereum nodes. They have this called debug tracer. So debug tracer is just a method in the node, and when where you provide here, as you can see, this is the RPC. So you say what is the method is debug tracer, and what are the params, which can be an object of transaction or block or hash. Here we're going to use an object, and then it's going to return to you some data like this, which is not going to be usable directly. So we can use something called a tracer. So we need first a debug call, then on top of it a tracer. So call tracers allow you to show the state in a way that we can understand. So we're going to see it here in API call directly. So this is an example. So here I'm using Node-REAL. Node-REAL have some APIs for simulation. So you can see here I'm calling the gRPC node with the method debug tracer, and this is the params, which is my transaction. And I'm saying to execute this, to simulate this on the latest, and use call tracer with logs. So I'm asking for the node to simulate this, use call tracer, and return to me what's going to happen if I use this, if I submit this transaction with the logs associated with it. And yeah, so this transaction is a real transaction. I think I'm still sharing my 1 second. Stop sharing. Let me share again so you can see what I'm talking about. So here, this is the, as I was saying, this is Go Ethereum. We have here the debug tracer, which is just a namespace here that you can use, and we can select which kind of tracer we want, which is here called tracer. So it returns data, as you can see here, the frames of executed during transaction. And I'm going to show you an example. It's a live one. So here I'm using Node-REAL API. They have simulation API. Here I'm specifying what is the method, which is debug trace call. This is the params, which is like an actual transaction before signing it. I got this from here, from 1 inch, trying to swap. This is Fusion. No, I don't want Fusion. 1 second. Here, Trust Wallet. I don't want this. Okay. I don't want Fusion. I want Classic. I swap. Okay, so no problem. So this is the data that I copied already. So I have from to value, and this is the call data. I'm saying to simulate this on the latest block and use call tracer with logs. And it returned me this data, this response, which is have this kind of calls and outputs. So the main idea is to go through all of these calls and identify events. Events going to be under something named log, as we saw, and we're going to see the address associated with those logs, topics, and data. So this is something familiar we saw already. So if we simulate this transaction, I mean, pay attention that it's not yet submitted, but it's just a simulation, how it's going to happen. And if we go through all these calls and we check the logs, as we saw here, we can technically know what are the events that's going to be emitted from this transaction if submitted. And because we can know beforehand all ERC20, ERC721, EIP event signatures, we can decode and knows if this transaction is affecting any assets. And by doing that, we can show to the user that this is affecting, let's say, his own assets if he signed this transaction. And this is something, there is a library already developed by Trustwallet to do this. It's called Wizard SDK. This Wizard SDK helps user to see transaction previews before it happens. And we can see here, this is how it works. So you see here there is a transaction, and so rather than showing directly to the user, what are we doing is we're trying to simulate this transaction and then show this preview to the user. All of this, how we do it, is the same thing we saw now in the workshop. We just go through events, we simulate them through Go Ethereum. Here in this case, we are using Node-REAL, and then we go through all events. We use our techniques that we saw in the first one. If you don't want to use that, you can use the Wizard SDK that I just showed right now. It's an open source. Maybe you can go there, and if you want to play around with logs and events, we have pretty much a lot of tests there and cases that we handled for different assets. You can see here, this is the new preview. This is how it's going to look for user. Rather than, let's say, this is the old one, you can see, but if we identify or go through all of these logs and let's say identify what are ERC20, ERC721 events that are going to be affected if the user signed this transaction, then we can enhance the user experience and security for user, where it's rather than showing this bunch of numbers, now we can show pretty much, let's say, enhanced UI with warnings of security because we know the outcomes. I think, let me stop sharing for a second. I'm going to share. Yeah, I think now you can see it much better. So yeah, as I said, so this is the main idea here from learning all of this is to enhance user security and user experience. So when it comes to AI, because you saw that before submitting transaction, if we simulate it and extract these assets movements, we can have it in structured data. So this is an example. If we provide the structured data to just an LLM, for example, ChatGPT, it's pretty much helps a lot by making that transaction more human readable. You see here, we provide for him assets in. This is the USDC amount 1,000 in and out. All of this we got from the logs, and then this transaction you exchange it your initial word. It's saying like you value that. So then if we do it differently, then it tells you that here we can define it's a new NFT by just events. It's minted or transferred from zero address. And there it's warning user, as you can see here, without knowing the market value of new NFT, it's uncertain, let's say you made a gain or incurred loss. So it's warning user to exercise with caution. We see other examples which are more, let's say, obvious. And it tells user that in this transaction, this transaction resulting in total losses of your asset. So this is how we really can use AI and with our knowledge, say, of simulation and extracting all of this data from a transaction before it happened, then let's say we send that to an AI or treat it by LLMs, then and ask it, let's say, to make this as much as human readable as possible. I'm pretty sure, especially if it's customized by user, by language, by advancement, or by knowledge, then the AI also can help us shaping user experience for user. So again, this is the presentation. You can be found here. The SDK, which I showed, Wizard SDK, if you want to learn more, or the source code can be found here. And if you want to check more about Go Ethereum, this is the public official documentation of Go Ethereum. So I guess that's pretty much from my side. Thank you so much for joining. And yeah.
Amazing. Thank you. Thank you very much, Abdel. This workshop is definitely super helpful for all of the audience, all of the developers who are watching this workshop sessions. And I believe they will have a much better understanding about everything you just taught. I think the time is a little bit tight because in 3 minutes there will be another workshop section is going to happen. So since I cannot see any questions right now in the group, like open group chat, I won't take Abdul too long to stay here with us. And just like the screen sharing showed, if you have any questions for what Abdul just presented, feel free to either scan the presentation again to go through all the content, or reach out to Abdul or Trust Wallet teams for any potential questions, or just reach out to DoraHacks team. We'll be happy to connect you with Abdul for the technical questions there. So yeah, I think that will be all. Thank you very much, Abdul, for your time and efforts and this amazing presentations for our communities. And yeah, amazing.
Thank you, Chris. Thank you, everyone. Bye.
Thank you. Thank you very much. Have a good day. Cheers. Bye.